It has been quite an adventure, and you have taken a journey through lots of concepts, ideas, opinions, and command line options. At this point, you should feel far more comfortable using Git than when we started. Perhaps rather than asking a colleague for advice, you will become the one everyone else comes to when they are having trouble using Git. I hope you've taken advantage of the opportunity to sharpen your Git skills with practice along the way. We began with a repository with a single README file. That was a great place to add notes and ideas as you gained knowledge and experience with Git throughout the course of this presentation. With this increased knowledge and confidence, you will travel unafraid into more complex problems and solutions with Git. In order to continue to help you along this journey, I want to share a few of the more common problems you are likely to encounter when trouble arises. For most, I will offer a solution. For some, I will challenge you to reason out the answer on your own, or even better, hack at it with a Git repository. The lessons we learn when puzzling through a problem on our own tend to be more permanent. We will look at a few topics: working with remote repositories, remote branches, changing commits, garbage collection. Although Git is a decentralized system, cooperation on projects is often done through a common hosted service. Using the Git protocol requires SSH connectivity. When troubleshooting connectivity, there are a couple of useful commands. Using the -t switch with the SSH command can provide a quick test of the connectivity. If that fails, you can add the verbose command. There is a great little set of instructions on the GitHub help pages. You may find that when attempting to push your changes to a shared repository, you get this message. It is likely this occurred because someone else on the team made changes since you last pulled from the repository. As we have learned, you could use git fetch, try to merge the changes appropriately, and move on. Or you can simply use this command. Then you can confidently push and continue your work. Remember that pull is really just a fetch and then merge. So this is an immediate indication your local changes are not based on the latest commit in the history. When this situation arises, I recommend you exit the editor and abort the merge and use the rebase method we just saw a moment ago. Remote branches in Git. It is important to understand that you cannot interact directly with remote branches. The refs to remote branches are only pointers to where the branch was when you last performed a pull. In order to interact with a branch, making commits or pushing, you will need to set up tracking of that branch. Using the -a switch shows all branches. The only tracking branch is master. You can view the remote branches with git checkout. Notice we are in detached head mode. We could check out to a new branch. Notice the success message. But this simpler syntax will set up the remote branch too. We use the very verbose switch again. Deleting a remote branch is something you will likely not do often. Here is the very strange syntax for this. In essence, you are pushing an empty branch to the remote ref. Changing commits. The commit command with --amend will open your editor and permit you to edit the commit message of your last commit. You can also use the -m to accomplish this on one line without opening the editor. Git rm file name will remove the file and tell Git to stop tracking it. But if you simply want to take a file out of the index without actually deleting it, add the --cached switch. Remember, when using git reset, the --hard will update your working directory to match what is in the index. In other words, any changes you may have in the local working directory will not be preserved. Undo the last commit. Maybe you forgot to include an important change or made a serious error in the commit message. Git reset /soft head -1. This will restore the working tree to where it was just before the last commit, as if the commit never occurred. But as we know, this only resets the head pointer. The actual commit object will remain, and you can see it with git reflog. It remains until you use garbage collection. Like any database, as a Git repository grows, it can accumulate lingering artifacts and dangling commits, specifically commit objects and tree objects that simply have no relevance anymore. Git has a garbage collection scheme that is activated automatically, but it is very, very conservative. You can, however, initiate the garbage collection process. Starting from the tip of every branch and from every tag, Git walks back through the graph, building a list of every commit it can reach. Once it's reached the end of every path, it deletes all the commits it did not visit. Let's try it on our packed project. Next, we will reveal your personal help aid.